Hey, what's up, guys? This is Chung here, and this time let's talk about another LeetCode problem here. uh, 1239 maximum length of a concatenated string with unique characters. All right, so you're given an array, a list of strings, and you need to pick up any of those elements in the array and concatenate any of them to be to be the to be a new string. And then if that new string doesn't have any duplicate characters, if that new string there are all the characters in the new string is unique, then you can just record that is a valid as. And among all those valid strings, just return the maximum possible length, right? For example, this one, uh, UN, right? So UN, and then you can concatenate IQ, right? Then this is like a valid one. And then, but for UN and UE, you can't because the U is duplicate. And IQ and the UE is fine. So you have four, sorry, basically you have two strings whose lengths are four. So the final result is four, right? Same thing here, right? Six, and for this one, just since you only have one string here, one array here, one element here, so the length will be the string itself. I mean, if this one is not the a duplicated one, right? So if this string itself is duplicated, basically you just return zero, right? So so this problem, how are we going to do it? So I mean, we can just use like a simple like backtracking uh depth first search, right? Basically, we try all the we start from each of this like we pick any of the element and we start uh going forward, right? Basically, we start from this one. We see okay, so if we can add this one as the our current one, right? If it's not, if it is, then we just keep going, right? So we just oh, this one is fine. How can I add this one? No, and then we just stop, right? And then that's done for this one, and then we start from here, right? From here, we we just try to add, oh, if this one is like we can add this one as the concatenated string, basically, right? If the new string is unique, then that's a new length. So while we're doing the traverse, every time we just keep updating the maximum length. And in the end, once we traversing, basically once we have tried all the permutation, not all the possible combinations of all the strings here, right? Then we just return the final result. Okay, so let's let's do it. So I think first let's define a backtracking method. You can also call it DFS. It's fine. So I will explain later why we call it. There's a backtracking concept here. So I would do like a current as, that's a current string, right? Basically, since we're starting from here and we just keep adding the element to our current string. So we need to have a value to store the current as, and then we're gonna have a current index here, right? We also need to store what's our current index so that we know we can start from this index to loop to try all the rest, right? And then okay, let's do so every time, right? Like I said, we're gonna have like an answer here at the as a global. Here it's gonna be zero. So every time when we see when we're in this backtracking method, we always update this like answer to check if the current as has a bigger length, right? So simply do this, right? Current as, right? That's how we update this one. And then we just do a for loop, right? Because we want to try all the following strings because we want to try all the combinations, right? Starting from here. So it's in range in range, so you know what? Let's do this. I and string, right? I string in enumerate, right? Enumerate array, right? Oh no, sorry, we cannot use the enumerate since we're going to starting from this index here. So we have to use a range here. And then basically we start from the current index, right? And to what? To the length of the array here. So let's do a length of the array at the beginning here. So here we're gonna basically for this current backtracking, right? We just do from this index we try all the possibles, right? Basically we try all the possible uh, arrays, all the possible elements starting from this index. And we're gonna have a current, we're gonna have a new string basically, right? New string equals to what? Equals to current string, right? Current string plus, right? Plus this index, right? That's gonna be our new string. And then we're gonna check, like I said, the new string has to be unique, right? Every time we have a new string, we need to see if it's unique. Well, the reason we check here, not at the beginning, because at the very beginning, when we start this backtracking at the first place, we'll be passing an empty string here. Yeah, so it's going to be an empty string, and then the index will be 0. So that's we can only so that we can check the we can only check the new string here. So and then we're gonna have like a let's define the helper function to check has duplicate, right? Has duplicate, and we're gonna have like a string here. We'll implement this has duplicate later, right? So every time when we have a new string, we check if this a new string doesn't have any duplicate, right? Then we can just keep going, right? Because if as long as it has a duplicate, we can simply stop this backtracking, right? So we just do a backtracking, right? Backtracking, and then we pass this new string here, right? With the index plus 1, right? Because that's the current sorry, the I plus 1. Yeah, not the index plus 1 because we're looping the current index here, right? So in the end, we just return that. So I think here is like the backtracking uh, idea here because every time uh, so basically the backtracking concept here. So among all the loops here, right? The whatever we pass here, so this current as, right, or this like current as shouldn't be impacted by the nested backtracking here. Since here we're not modifying the current, we're not modifying the current index. Instead, we're creating a new uh, a string, right? So that we don't need to do a backtracking after the backtracking method, backtracking like rest restore something like that, right? Let's assuming, okay, let's say we making instead of like let's say we have a current array here, right? Let's assuming we have an array here, current array. The array will store the element, right? And in this case, let's say we do uh so in this case it's gonna be we'll not create a new string here. Instead we'll do a array dot append, right? So we'll do append to this new array. And then let's assuming, okay, so we check this array, the new string doesn't have the new array doesn't have any duplicate, and we just pass this current array to to here, right? But remember, since we're doing the in-place modification on this array here, so basically this one will keep appending, right? And by the time this is done, and when we comes to the second for loop here, this current array will already have like the previous result appended, right? Which we don't need. So then basically that's how the backtracking concept kicks in. So every time we we append something and we do a backtracking, and once everything's done, we just need to do array dot pop, right? So that we're sure once this for loop is done, we know the current array will be restored back to when it was to where it was, right? To what it was. Basically, when the second one started, the current array will be at the basically at the fresh uh, status, right? It won't be so it's ready to do another for loop because those each for loop they are kind of equal, right? They have a same that they should have the same clear base as it starts from this backtracking method, right? That's how the backtracking concept kicks in. But in this case, we're not modifying this current current as here. Instead, we're doing like we create a new one, right? So the next time when it comes in, still current as still the same. So we don't need to worry about this backtracking thing here, right? And now let's implement this like has duplicate, right? So here I'm gonna introduce two ways of check the duplicates here. So the first one is it's very obvious. We just do a set, right? Basically we just return, right? Return if the length s equals to not equals to, right? Not equals to the what the length. We convert the s to a set, right? So basically, if there's any duplicate in the s, the length of set s will be smaller than the length s, right? So in this case, that will be true, right? And that's how we implement this one. And so I think that's pretty much it is, right? So it's pretty straightforward. So we start from zero. Basically, we try each of the, the element here, and we try all the possible combinations. In the end, we just return that. Let's try to run it. Uh, oh, sorry. Yeah, since we're updating the global variables, we need to do a non-local statement here. Uh, State that the answer is like it's not a local one, it's a global one. Cool. See, and yeah, this is very straightforward, But I also, what I would also like to talk about another way of checking the duplicate in the string s, which is the bit manipulation. So, and let's think about how can we you know, for those for those people who are not interested in the bit manipulations at all, you guys can just stop here, right? You don't have to continue. Thank you so much for watching the videos. So, and in the remaining of the videos, I'm gonna talk about how can we implement this one with a bit manipulation. So, for example here, right? Let's say we have a B, A, and B, right? So that's a string. How can we check if the B is a duplicate? So, okay, so first, we get the relative positions from B to A, right? Basically, we just do a ask code of B and we minus A. So basically, it's relative position from B to A, right? So in this case, it's gonna be no, let's do a it's gonna be one, right? It's gonna be one. Let's do a you know what? Let's do a C here. So let's do a CBC. Yeah. So the value for this for C to A will be 2, right? So what do? We have this 2, right? So we're gonna have like a 1, we're gonna shift this one for each of the positions here. We're gonna shift this one to basically we're gonna convert this 2 to what? To this to 1 0 0. Basically we'll do a 2 sorry, we'll do a 1 shift to left, then we'll have this 1 0 0, right? and then that's the so we're gonna have like a global like a variables here to store current bit values all together, right? And then so we have 100, right? And then we have b here, right? So what is the value for b? B is 1, right? So we're gonna have 1 shift to left to by 1, right? So we have like 10 in this case, right? 10. And every time when we have a new like bit values here, we'll do a OR. Basically, we'll do a OR with this one. So we'll do a 100 or 10, right? So what's the result here? Gonna be a 110, right? And then same thing, we just keep doing it until what? Until we see a duplicate, right? And let's check this out. So we have a duplicate here. What do we have? Same thing, right? So we're gonna have like a 100 again, right? By shifting the one uh to the left by 2, right? So we're gonna have 100. And okay, let's see here. Oh, okay, and every time when we see a new numbers, we'll also check, right? We check the current if the current number if the current bit, right, and and this new number and this new number, if it's greater than 0. If it's greater than 0, we know it has like a duplicate number, duplicate string. Why, right? Because if it's not duplicated, and the end here will always give us zero result. So what is the end here, right? End means uh as long as there's a 0, or as long as unless they're not both 1, the result will always be 0, right? So we'll only have a 1 somewhere if those two, both of the the position, the bit position 1, then we'll have like 1. So we'll have like a something bigger than 0, right? So in this case, so let's say for 1000, and when we see this 10 here, we do a 100 and 0 10. What's the value here? 1, right? So there's no duplicate. And every time when we see that there's new duplicate, we update this thing, we update this value here. So the next step will be a 110, right? And what? And 100, right? See? So now we have 1 here, right? So what's the value here? 100, right? Which will be 4, right? 4, which will be bigger than 0. That's how we detect a duplicated string by using the bit manipulation here. Again, so the key point is here. First, every time we keep adding all the net the values together, like this together, and let's see, if if they're all different, if they're all if every time they're all the numbers are different, this end, right? This end, every time we add a new number and then we do an AND, it will always be 0, because all the all the bits value will be different. Why is that? Because we are basically we are for each distinct value right here, we always get the distance from B from this current character to A, right? So for different characters, this distance will always be different, right? So it's gonna be from 0 to 25, right? So basically, we're gonna have like a bit array here from 0, 0, right, until 0. So the range here will be 26, basically, right? And for each of the characters, it will be represented by the one somewhere, right? So one, one, and one, right? And if there's a since okay, so since we're if each character they're both unique, so when we do this uh or here, right? So we'll always get this. When we do this and here, right? We'll always get like 0 because there won't be any uh ones appear at the same place, right? As long as there's a 0 somewhere, the final result will be 0. But if there's a duplicate string here, right? So which means we'll be having like two ones appear at the same place here, then this final result will be greater than 0, and then we know we have find a duplicate uh, string. Cool. So let's try to implement this, right? So we're gonna have like a current, bit value here, right? At the beginning, it's gonna be 0, and we just loop this s here, right? In enumerate, right? Since we're going to use this index to do the shift, right? Shift to the left, and s, right? And we do what? We uh if, right? If oh sorry, we have to get the ask chain difference, right? So it can be ask. It's not ask. It's gonna be the we'll just call it the value here, right? So what's that? Ord, right? Ordin ordinate of the at the c, which is the ordinal. Yeah, I had to look it up. So what does this ord mean? It seems like it means ordinal of c and minus the ordinal of the a, right? That's how we get the values here. So the value is going to be from 0 to 25. And then we just do a if, right? So we check if the current bit and and, right? And what? And this like one, right? Shifted to the left by the value, by this value is greater than 0, right? Like we said. So we're gonna have like return true, right? So then we find a duplicate. Otherwise we do what? Otherwise we just update this bit, right? We keep counting all the values here. Basically we segregate all the bit value into this one so that we know on which position we have a one, right? So how we do that by doing a or here, right? Or the basically the current this value, right? The current. So, yeah, sorry about my Chinese input here. Value, right? And then if everything works fine, then we return false, which means there's no duplicate. So let's see here. Okay, let's run it. Submit. Cool. All right. Okay, cool, guys. Thank you for watching the video. I know this bit manipulation is kind of annoying. Uh, anyway, hope you guys enjoy it, and I'll be seeing you guys soon. Thank you. Bye bye.